Engineering, Dr. Brijesh Yadav, Chief Guest, Dr. TMV Suryanarayan, our guest of honor, and all dear participants. I, Urvashi Malani, research scholar from SVNIT Surat, welcome you all to the inaugural function of 2-week ATAL FDP on rainwater harvesting for sustainable development of groundwater. Without getting delayed, let's start the function by prayer. I would like to call my colleague Ayushi Panchal for Saraswati Vandana.
Thank you, ma'am. या कुंदेन्द्र तुषार हार धवला या शुभ्रवस्त्रावृता या वीणा वरदण्ड मण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निशेषजाड्यापहा. Thank you.
Thank you very much, Ayushi. I request Ayushi Panchal to introduce Dr. SM Yadav, Professor and Coordinator of the ATAL FDP, to address the participants.
Thank you, ma'am. Dr. Sanjay Kumar M. Yadav is working as a Professor of Water Resources Engineering in the Department of Civil Engineering at SVNIT Surat, Gujarat. His research areas are fluvial hydraulics, reservoir operation, sediment and sediment yield and hydropower, hydrology and climate change, application of soft computing techniques, as well as groundwater recharge and sediment transport. He has completed his doctoral degree in Civil Engineering Department from SVNIT Surat. He has guided 8 doctoral students and guiding 8 PhD scholars as well as 50 dissertation projects. He has completed number of design projects like check dam design, stormwater network design, water supply network design, water conservation projects, recharging structures and modeling of drainage channel as well as flood mitigation measures for Ganga Basin rivers. He has imparted flood modeling and analysis training to more than 500 research scholars, assistant professors, and engineering students from India as well as institutions like Asian Institute of Technology, Thailand. He has been appointed as an expert member by Central Water Commission as a panel member for the ADB project Climate Change Adaptation Guidelines for Coastal Project and Management in India. He has published more than 50 research articles in peer-reviewed journals and 100 papers in national and international conference proceedings. He has also conducted more than 50 seminars and workshops and delivered expert lectures to academic institutes as well as industries. Now I would like to invite Dr. SM Yadav for addressing the participants and introducing about the course. Thank you, sir.
Thank you, Ayushi. Good evening, everyone. Chief guest of today's function, Dr. Brijesh Yadav. Guest of honor, Dr. TMV Suryanarayan. In-charge director, Dr. CD Modera. Professor and in-charge head, Dr. CH Solanki. Dr. PL Patel. Faculty members and dear participants. It gives me immense pleasure to welcome you all at ATAL FDP. This FDP is planned in 2 modes, 1 week online and 1 week offline. So as a part of online mode, we all are here for the inaugural function of ATAL FDP. This FDP is scheduled from evening 7 p.m. to 9:30 p.m. As per the ATAL guideline, we'll have 2 sessions daily, one from 7 to 7:50 p.m. and other from 8 to 8:50 p.m. and night 9 to 9:30 p.m. will be for interaction, question answers and discussion. I am happy to share with you that the renowned professors and field practitioners, including industry people, have agreed to deliver expert lecture as well as share their field experiences with the participant. In case of online mode, we have different topics covered. Out of that, aquifer recharge management in arid and semi-arid salt affected region by Dr. Brijesh Yadav, an enterprise approach to develop membrane-based solution by Dr. Adil Dhalta, Managing Director, START, Singapore, NTU, AI-based estimation of regional groundwater fluctuation using GRESS data, Dr. Rajiv Bhattacharya, Professor, IIT Guwahati, practical aspects of aquifer storage and recovery by Dr. Gopal Krishnan. We have two presentations on quality of groundwater, hydrogeochemical studies of diffuse contamination in an irrigation command area and in its effect on groundwater by Reshma Patel, and impact of point and non-point solution sources on river water quality by Dr. Namrata Jariwala. There will be two case studies discussed during this online session, one by Dr. TMV Suryanarayan, Director REMI, on different approaches towards rainwater harvesting, special emphasis on educational institutions, and design of water conservation pond for artificial recharge of groundwater by myself. There will be deliberations on groundwater recharge, combined effect of flood and drought mitigation, as well as the surface recharge by Dr. M.B. Joshi, retired General Manager, Sardar Sarovar Narmada Nigam Limited. During offline classes, we have one field visit wherein the participant will get chance to see the recharge system in one of the prestigious Sumul dairy of Surat. At the same time, there will be two sessions in which the participants will get chance to carry out or to find out the source of water, exactly where the water is available, and a recharge well where a well can be excavated, followed by how to find out or how to check whether the well is capable of recharging or not. That field studies have been arranged, 3 field studies have been arranged during the offline course, apart from the mandatory sessions on yoga, mandatory session on national education policy, and the sessions on IS code applications for groundwater management, groundwater recharge, and groundwater quality. I hope the participants will get enough chance to learn the subject matter. At the same time, they will enjoy both online and offline sessions. Thank you very much.
Thank you very much, sir, for a brief introduction about the course. I hope we will all have a joyful learning. It is our pleasure to have Dr. C.H. Solanki, in charge Head of Department, Department of Civil Engineering, with us. I would like to request Ayushi to introduce Dr. C.H. Solanki.
Professor C.H. Solanki is a professor in geotechnical engineering in the Department of Civil Engineering at SVNIT Surat. He is working since 1991 at the campus, and he has guided more than 59 postgraduate dissertation and 23 PhD theses. He is present research supervisor of 8 ongoing PhD research scholars. He has published more than 200 research papers in reputed international and national journals and conferences. He has received Shri M.S. Jain Biennial Award for Best Paper in IGC 2013, Professor Dinesh Mohan Award in IGC 2017, and Distinguished Faculty Award from the Venus International Faculty Awards. He has also received many Best Paper awards in different conferences. Professor Solanki has organized more than 20 national level events, including STTP, FDP, conferences, and seminars. He was the chairman of the Indian Geotechnical Conference in 2019, Surat. He has been elected as member of Executive Committee of Indian Geotechnical Society for the 4 terms from 2015 to 2021. He has 31 years of teaching experience for undergraduate and postgraduate students. Now I would like to call Professor C.H. Solanki to address the participants. Over to you, sir.
Okay. Thank you. May I audible to you?
Yes, sir. Yes, sir, you're audible.
Thank you. I thank Professor S.M. Yadav for inviting me here to join this inaugural function of the ATAL short-term training program on rainwater harvesting for sustainable groundwater development. First of all, I congratulate Professor S.M. Yadav and Dr. Namrata Jariwala for getting approved this short-term training program of ATAL. As far as the civil engineering department of SVNIT is concerned, we do have total 43 regular faculty members in the department. We are running 7 postgraduate programs in the civil engineering department. The department is very much involved in the consultancy projects of the different areas of the civil engineering, and most of all the faculty members are involved in the consultancy work. As far as the research projects are concerned, most of the faculties have approved the research projects from the DST grant, and some of the faculties have also got the research project of the amount more than 1.5 crores too. We do have the good experienced faculties, like Professor S.M. Yadav is having experience of 32 years in this institute, only at the SVRCET, that is at SVNIT Surat. Like many of the faculty members are experienced here in this department. As far as the paper publications of the department are concerned, all the faculty members are publishing the good number of papers and the quality papers. Many of the faculty members have published more than 250 papers too in the department individually. Laboratories of all the areas of the civil engineering are well equipped in our department. We do have good strength of the PhD students in the department. I don't know the exact figure, but around 150 to 200 PhD students are enrolled in the department. And many of the faculty members have guided good number of PhD students in the department. As Professor Yadav is very active and is continuously organizing the various events in the civil engineering department, and particularly to the water resource areas. The department faculties are very much involved in organizing the good quality events such as the conferences, seminars, workshops, and short-term training programs. And I once again congratulate Professor S.M. Yadav and Dr. Namrata Jariwala for organizing this excellent event and very well planned event. As far as the STTP is concerned, it is a good idea to have 1 week of online program and another week of the offline program. So I wish you happy and enjoyable STTP for the 2 weeks. Thank you.
Thank you very much, sir, for enlightening us about the department and departmental activities. We are delighted to have Dr. TMV Suryanarayana, Director REMI, and guest of honor for today's inaugural session with us. I request Ayushi to introduce Dr. TMV Suryanarayana. Ayushi.
Yes, ma'am. Dr. T.M.V. Suryanarayana is the Director of Water Resources Engineering and Management Institute, Faculty of Technology and Engineering at MS University, Vadodara. He has more than 20 years of teaching experience. He has guided 7 PhD students and about 123 MTech dissertation projects. He has been engaged with the research projects by AICTE and CEP as nodal PI with the lead from IIT Roorkee. He has 149 research papers in peer-reviewed journals, 5 books and 24 books chapters. He has reviewed 96 articles from national and international research papers. 51 lectures have been delivered by Professor T.M.V. Suryanarayana. He has been the fellow member of IWRS, ISH and IASH France. He is the executive committee member of IWRS from 2013 to 2015 and AHI from 2020 to 2022. Now I would like to call Dr. Suryanarayana to share the few words.
Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir.
Yeah, thank you. Professor Brijesh Yadav ji, Chief Guest of the program, Dr. C.D. Modera ji, Dr. C.H. Solanki ji, Dr. P.L. Patel ji, Dr. P.V. Timbadia, and Dr. Namrata Jariwala ji, who is one of the co-coordinators of this program, and one of the main coordinators of this program, Dr. S.M. Yadav ji. Congratulations to you, both coordinators, for wonderful sanction. First thing is you got sanction of this, and for number of participants who have got registered, and the various variety of speakers you have chosen, right from IITs, NITs, and private and government organizations, and including NIH. Well, when we talk about surface water resources, whatever the water is available, only 60% of water we can use. So the alternate source which we have is, of course, only groundwater. And as per the records of the literature, India is the country which is the largest withdrawal of groundwater. And 1/4 of the global withdrawal of groundwater goes with India only. In recent reports of the Hindu newspaper, it has been commented that more than the groundwater extracted, the groundwater is now getting recharged with various practices, but then it needs to be extensively increased, as we all know, because groundwater maximum when you see food and water, drinking water are main requirements for us. More than 60%, 60, more than 60% of irrigated agriculture, groundwater is being used in our country. And when it comes to drinking water supplies, again, the literature says that almost 85% of the drinking water supplies is through groundwater. So undoubtedly, need of the hour, and a perfect time to launch such a program, that too in hybrid mode, one in offline and one in online. And as sir has clearly indicated that there will be also field studies and field visits. I hope all the participants will get undoubtedly benefit from this 2 weeks FTP, number one. And number two, hopefully all the participants will share the extractions, the knowledge obtained in these 2 weeks FTP to other colleagues and friends and natives of our country to know the importance of groundwater being recharged. So I congratulate once again the organizers for this program called as Rainwater Harvesting for Sustainable Development of Groundwater under ATAL Training and Learning Faculty Development Program in hybrid mode. Congratulations to you and congratulations to the participants. Hope the knowledge will go a long way to the participants. Only one thing to say in final as a bottom line. Generally, there is a government rule that groundwater needs to be recharged at every scale, and people does that. But it needs to be done with complete seriousness, so that truly by studying the hydrogeology and the geology and everything, so that the water will reach to the safest aquifers. Congratulations once again. Thank you for inviting me, Professor S.M. Yadav. Thank you once again.
Thank you, sir, for your gentle words. It is our pleasure to have Dr. Brijesh Yadav, Professor and Head, Department of Hydrology from IIT Roorkee, and Chief Guest of our today's inaugural session with us. I request Ayushi to introduce Dr. Brijesh Yadav to the participants.
Thank you, ma'am. Dr. Brijesh Yadav is a professor and head of the Department of Hydrology at IIT Roorkee. He has completed his PhD in mathematical model of phytoextraction for contaminated soils in April 2008 from Department of Environmental Resources, UNESCO, Institute of Water Education, Netherlands. He has completed his master's in water resources engineering from IIT Delhi in year 2000. His research interests are groundwater flow and contaminant transport modeling, plant soil moisture interaction, heavy metals, moisture flow and contaminant transport modeling, saltwater intrusion, bioremedial of non-aqueous phase liquid, polluted soils, multi-phase flow, and carbon sequestration in deep surface. He is the member of International Association of Hydrological Sciences, International Society of Porous Media, American Geophysical Union, and Indian Association of Hydrologists, as well as International Association of Engineers. He has guided 6 PhD candidates and guiding 8 PhD candidates. He has been associated with research projects such as an efficient aquifer storage method for enhanced recovery of recharged freshwater in saline regions, as well as co-creating sustainable agri-water use in Hindun sub-basin, a multi-scale participatory approach. He has been associated with 18 consultancy projects of worth rupees 8 crore. He has coordinated more than 15 workshops as well as courses. He has been ranked in top 10 outstanding teachers list in PG category consequently for last 4 years. We have been honored to have Dr. Brijesh Yadav as an expert to our FDP program. Now I would like to call Dr. Brijesh Yadav to deliver his lecture. Over to you, sir.
Thank you, Ayushi and Rusi, for your kind introduction. And I also thanks to the organizers from NIT Surat for giving me this honor to decide this session for this opening of this 2-week course. Professor C.D. Modera Sahab, Acting Director, Solanki Sahab, Professor Solanki Sahab, he is the head of the department. PM Patel Sahab, owner Professor Surya Narayan Sahab, good to see you again. And Professor Sanjay Yadav Sahab, and also the co-convener of this event, Dr. Mamata Jariwala. So it is my pleasure again to be part of this meticulously planned 2 weeks of the training program on the very timely topic, that is the sustainable, you can say, the use of the rainwater harvesting for sustainable development of the groundwater resources. Why I'm saying it is a timely topic, because recently Professor Surya Narayan has highlighted the importance of the groundwater. If you look at the entire water budget of our planet, we see that most of the water is not usable directly. So why it is not directly usable? Because 90%, or you can say 97% of the water is saline, which is in oceans and the saline water bodies. The remaining water, that is going to be 3% of this planet Earth, is going to be the fresh water. Now, if you look at the distribution of this 3% of our planet water, that is fresh water, you will see that most of that, it is there in like 70% is in the glaciers. Indeed, we cannot directly utilize these ice caps and the glaciers. The remaining is the 30% is the groundwater and 1% is the fresh water. So whatever the large rivers, lakes, what we see on the planet, they comprises of 1%, and the remaining is the 30% of the groundwater. If you look at the groundwater sources of this 30%, much of that is not going to be fresh water. Even more than 50% of the groundwater is saline in nature. So we are left with the 45% of the fresh groundwater. And then this is mostly because when you go for deeper horizons, the quantity and the economical viable of the extraction of this groundwater is not feasible. Therefore, the sustainable development of the groundwater sources is important. And that if you compare the surface and the groundwater sources together, look at the availability of the surface water. We know that surface water is available throughout the year and perennial. It's not available throughout the year. But if you look at the groundwater, it is more reliable. Why do we call the groundwater as a more reliable source? Because if you go for the extreme events, it is the groundwater where we can rely. Distributed indeed, and during the droughts, during the floods, even we rely more on the groundwater rather than the fresh water. But it doesn't mean that the groundwater sources, which we are going to have more reliable source for the fresh water, is going to have some issues. So groundwater has issues in terms of the depletion. So when we extract the groundwater more than its natural recharging, indeed it is going to deplete more extraction and groundwater table goes down. In some areas, there's an opposite issue of the depletion. When the groundwater table comes nearby, that is what we call issues. And there may be some groundwater contamination that can be because of the seawater ingress, or it can be by anthropogenic or geogenic pollutants. So those are the issues with the groundwater. And this course is tackling nicely the use of the surface water, which is going to be supplied because the groundwater is not like other conventional sources. it gets rejuvenated every year because of the surface water, or you can say the precipitation which is taking place. So for rejuvenating, replenishing this groundwater resources, we have to look at our source, and the source is going to be rainwater. So once we are able to tap the, that is going to be, we presume that is going to be the fresh water, and that can be used for, you can say, recharging our underlying aquifers. So that use of this underlying aquifer for recharging this available source of the fresh water is going to be, I think, the main aim of this FDP, 2 weeks of the FDP. And it is very nice to see that 1 week of the FDP is kept online, where the persons, or maybe the participants who are not able to travel because of the many concerns, they can join that one. And the remaining 1%, where most of the things are, I think, based on the field work, that is what I could get from Sanjay. And also the some other handle, you can say the modules which has been kept for the second week of this training program. So it is very nicely arranged, planned, and meticulously going to be executed from the conveners. So my hats off to both the conveners as well as the entire team of the students and the other supporting staff and the faculty colleagues of the Department of the Civil Engineering, SVNIT Surat. So once again, thank you very much for giving me this honor for presiding this session of the inaugural of this 2-week training program. Thank you, Ayushi.
Thank you very much, sir. We are very grateful to have Dr. C.D. Modera, in charge director of SVNIT Surat, with us. I request Ayushi to introduce Dr. C.D. Modera.
Thank you, ma'am. Dr. C.D. Modera is professor at Civil Engineering Department at SVNIT Surat. He has completed his PhD in Civil Engineering from IIT Bombay in year 2001. He has been associated with Sardar Sarovar Narmada Project Limited at Dabhoi and Bharuch, Gujarat. He has published 125 research articles in various conferences and journals at national and international level. He has guided 22 PhD students and 50 MTech students. He has delivered 32 expert lectures and has been the member of various academic committees at Institute. Now I would like to call Dr. C.D. Modera to address the participants and share his views. Thank you, sir.
Good evening, one and all. Chief guest Brijesh Yadav Sahab, guest of honor Surya Narayan Sahab, coordinator Professor S.M. Yadav, Dr. N.D. Jariwala, in-charge head Dr. C.H. Solanki, Professor P.L. Patel, student team, Master of Ceremony Ayushi and Urvashi, and dear participants. It is my great privilege to introduce or give the information about the institute. First of all, Professor Shukla, sir, regular director, has conveyed best wishes for this ATAL FDP of 2 weeks. So far as our institute is concerned, it was established in 1961, one of the RECs, Regional Engineering College, for imparting technical education, in particular civil, mechanical and electrical core branch. Later on, electronics engineer branch was introduced in 1983-84. Then computer engineering and production engineering was introduced 1988-89. And last, chemical engineer in 1995 and 96. That RECs in during 4th December 2002, it was declared deemed university under UGC Act 1956. Then after in 15 August 2007, that status was given as Institute of National Importance. So now we are full-fledged, centrally funded Institute NIT, SVNIT, Sardar Vallabhbhai National Institute of Technology. We have this institute offering 6 UG program, 19 PG program, and 3 program MSc integrated courses. Then PhD program in all discipline it is existing. All department well equipped, and so far as faculty is concerned, we have sanction post 296. Of course, it was requirement derived in 2011-12. Now it is increased by 415 or 25. But however, in place we have 228, that 425 yet to be sanctioned. At present, sanction strength is 296, in place 228, so 68 remaining faculty position will be filled as a dean faculty welfare work is assigned and it is in progress. We have non-teaching faculty very less at present, and we have already advertised the 120 posts in to be filled. That date is already over, 2nd December for online, and offline is again 8 December. So this was the little information about the our institute. The details is already given in website. Thank you very much for inviting me, Professor S.M. Yadav and Professor Namrata Jariwala, for inviting me in this inaugural function. ATAL FDP, I noted 2 weeks. 1 week is for offline, another week is will be the online. So it is kind of hybrid mode so far as week is concerned. I also noted the various, you can say, experts from industry and institute also called, also noted the field visit, that Sumul Dairy and other, and that is very much required. Any FDP, I think field visit will give the very good, you can say, insight about the, title of the program or gist of the program. I'm really appreciate for the conducting or plan the field visit about the Sumul Dairy. So once again, very much thankful to participant, because of you are backbone of this success of this event, ATAL FDP 2 weeks. So thank you very much for the participant, and thank you one and all, and wish you all the best for the success. Thank you.
Thank you very much, sir, for enlightening the participants about the institute. Now, I request Ayushi to introduce Dr. Namrata Jariwala, Course Coordinator of ATAL FDP, to present vote of thanks.
Thank you, ma'am. Dr. Namrata Jariwala is working as Assistant Professor in Department of Civil Engineering at SVNIT Surat. She is having 20 years of teaching experience. She has published 25 papers in peer-reviewed journals. She has guided 3 PhD candidates and 21 MTech students. She has wide experience in development of laboratories in the field of environmental engineering. She has handled various consultancy projects of SNC and other local government bodies in area of water and wastewater treatment as well as solid waste management. She is working in the research area of health and risk studies of environmental engineering, air pollution related studies, soft computing techniques in environmental engineering as well as fuzzy logic with applications. Now I would like to invite Dr. Namrata Jariwala for delivering the vote of the thanks. Over to you, ma'am.
Thank you, Ayushi. Good evening, all. Respected Dr. C.D. Modera, sir, In-Charge Director, SVNIT Surat. Dr. C.H. Solanki, In-Charge Head, Civil Engineering Department, SVNIT Surat. Dr. Brijesh Yadav, Professor and Head, IIT Roorkee, Chief Guest of today's function. Dr. T.M.V. Surya, sir, Director, RAMI, Guest of Honor of today's function. My faculty colleague, Dr. S.M. Yadav, dear participants and my dear students. As a matter of pride, I am here to end this inaugural session. But before this, let me introduce and let me thank some of the personalities and the administrative staff of SVNIT Surat. First of all, I would like to thank ATAL, Director, Secretary, and the administrative staff to approve this ATAL FDP in a hybrid mode. As mentioned, 1 week will be online and the second week will be in offline. We are thankful to Dr. Anupam Sukla, Director, SVNIT Surat, and Dr. G.J. Joshi, sir, Professor and Head, Civil Engineering Department, for their continuous motivations and support for organizing this event. We are thankful to Dr. Brijesh Yadav and Dr. Surya, sir, for sharing their valuable time for this inaugural session, as well as they are delivering an expert talk in this FDP also. We are thankful to all the speakers who will join with us in online mode during the first week of FDP, and all the eminent field practitioners and experts who will join with us, and they will reach to SVNIT for delivering their expertise to the participants during the second week, that is 12th December to 16th December 2022. At last, I will thank all the administrative staff of SVNIT, Dean Student Welfare, Dean Academic, Chief Warden, all the wardens. Special thank to Dr. Modera sir, Dr. Solanki sir, and account section of SVNIT Surat. I'm also thankful to Dr. Yadav because he has taken a lot of effort for making this event success. We are thankful to all the participants and supporting staff of SVNIT Surat to make this event grand success. I hope the deliverable made in this event will be helpful to all the participants, and the outcome, whatever is we require to achieve, that will be achieved at a very fast. Thank you all.
Thank you, Namrata ma'am. With this, we conclude the inaugural session. Thank you all the guests and participants for joining the inaugural session. After the break of 5 minutes, we will start with our first session of ATAL FDP. All the participants are requested to join with the same link. Thank you.
Dr. Brijesh sir, please share your screen meanwhile.
Yeah, I am sorry for the delay. I was in impression that I am to come at 6 p.m. 7 p.m. for the lecture.
7 p.m. Okay.
And I missed that 6:30 timing when you, I think, shared the information via
Yeah.
WhatsApp. Yeah.
No problem, sir. So you can comfortably share your screen so that we can start in 2-3 minutes.
No problem. Can you see it?
Yes, sir.
And
Yes,
I'm
sir, it is
trying
visible. Yes, sir, it is.
I'm trying to move the slides. Is it moving?
Yes, sir, it is moving.
Okay, great. Great. So I hope all the participants are here in India, or are they coming from abroad as well? Because the timing is quite late in the evening. So,
Sir, all are from India. As per the ATAL, they want one online program to be conducted in the evening, so that the faculty members, those who are serving, right, their regular schedule don't get disturbed.
yeah, got it. Got it.
And at the same time, they can attend the FDP. Sir, make it PowerPoint mode, PPT mode. Yes.
Yes, now it is.
So within 2 minutes, sir, you can start.
Sure. And how much time I supposed to take? Maybe I'll, because the next lecture is fixed at 8 p.m. So
No
yeah.
problem, sir. You can continue up to 8:15, 8:30.
Fine.
1 hour. 1 hour.
So shall I start? I think I can see all the participants are there. So welcome.
Yes, sir, you can. Yes, sir. Please,
Welcome
please.
everyone. So welcome to this the first lecture of this rainwater harvesting for sustainable development of groundwater, organized by SVNIT Surat under FDP scheme. The title of this talk is Aquifer Recharge Management in Arid and Semi-Arid Saline Regions. So I'm keeping the words here, the Aquifer recharge management. Some people call MAR, manage Aquifer recharge. Some people call ASR and other techniques. So these are the same thing here. Why do we call it in arid and semi-arid region? Because most of the groundwater in our country, like in India or Indian subcontinent, we are having the arid or semi-arid type of the climatic conditions. And the most our groundwater, which I was telling in the initial, it is not necessarily going to be fresh water. So most of these, you can say more than 50% or in general, 55% of the entire world groundwater is saline in nature. But if you look at the Indian subcontinent, I'll give you some brief information about this salinity issue and how to go for the management for recharge in salt-affected groundwater regions. So since this is the first lecture, so I just copied few more slides here before I'll go for the main topics. This is the hydrologic cycle. I think most of you are aware about the hydrologic cycle. That water goes into the atmosphere because of the energy provided with the sky, and then because of condensation, the precipitation is taking place because of the soil getting the favorable conditions here. So the water falls from the atmosphere to the surface of the ground here. And after reaching this water here at the surface, some goes into the surface runoff into the sea, and some goes back into the atmosphere. So indeed, we cannot control the airport transpiration, which is lost from this land mass or from the water bodies. And our objective is to sometimes to check this runoff, because during the rainy season, during the monsoon season, most of the water goes unutilized into the streams, and ultimately it meets to the surface water, seawater bodies here. Now, to catch the rainwater harvesting, that is what the title of this FDP program is kept. So, because for recharging the groundwater, that one is the natural process that is shown here by the vertical arrows here. So that is going to be the infiltration, which is the process by which the water goes from the surface to the subsurface, and this infiltrating water is going to be rejuvenating to the groundwater table, and that's the region that during the monsoon and the post-monsoon season we see the water table, groundwater table rises up and it comes nearby to the surface. And during the post-monsoon and the pre-monsoon season, you might observe that because of the extraction or because of the groundwater flow or the base flow towards the streams or towards the nearby water bodies, the groundwater table goes down. And when we go for the more anthropogenic activities, so we extract the more and more groundwater, and that is going to enhance this depletion of the groundwater resources. And for checking this long-term, you can say, the depletion of the groundwater, we are having some human intervention in terms of the holding this the rainwater and diverting this rainwater into the subsurface by accelerated means of different type of the recharging mechanism. So the objective of rainwater harvesting and the groundwater recharging is to replenish the groundwater sources as much as possible, so that we can you can say fulfill the whatever the groundwater utilization demand is there during the dry season or during the non-monsoon period. Now, if you look at the general distribution of the water sources over the planet, 3% is the fresh water, rest is the saline groundwater. That is going to saline water. That is going to be 97%. 3% of the fresh water, if you look at distribution, so 30% is the groundwater which contains. So this is going to be huge potential for its sustainable development, because we cannot use the ice caps and the glaciers, which is going to be around 70% of this water resources. Indeed, we have developed nicely the surface water resources that is going to comprising around 1%. So our focus of this FDP and also this lecture is on the groundwater sources. That is the 30% of the available freshwater resources. Out of this groundwater, some part is going to be not accessible directly for us, because either it is in the deeper resources or it is not, yield is not going to be so sufficient. And the remaining is also affected by the pollutant, including salinity and other geogenic and anthropogenic contaminants. So the fresh groundwater resources is also very limited. So therefore, dynamic groundwater resources, which is there in the shallow, you can say, the subsurface strata, geological formation, we have to manage it judicially so that our requirement of the fresh water can be met nicely. Now, if you look at the facts and the figures of the groundwater, so Surya Narayan was also telling you briefly about his address, that groundwater provides almost half of the drinking worldwide. So our 50% of the drinking water in general, I'm telling, is met from the groundwater, and about 40% of the water which is utilized in the irrigation and about 1/3 of the supply required in industrial, because we are having the three sectors where the demand of the fresh water is there. One in industrial water requirement, domestic, and the agriculture sector. So 40% water in the irrigation and 1/3 is going to be for industrial purpose, is going to be supplied from the water from the groundwater. Not only the groundwater sustains the ecosystem, but also water sustains the ecosystem, because during the non-monsoon period, most of the rivers which are perennial, they are contributing to the base flow. So base flow is continuously contributing to the rivers and the streams, and that is the reason they are perennial rivers. So that is needed to maintain the ecosystem of the surface water bodies through these groundwater sources, and it is also an important factor in climate change adaptation. So surface water bodies are directly, susceptible for the climate change. But if you look at the groundwater, because the groundwater is not at the surface, there's a, you can say, buffer zone in terms of the unsaturated zone or the vadose zone, which doesn't allow the interaction of the groundwater with surrounding climatic conditions. So the impact of these climatic conditions, so climate change is going to be least in terms of the groundwater as compared to the surface water sources. So it is going to be more resilient as compared to the surface water sources. And if you look at with the rise in the water scarcity and the decrease in the availability of the surface water, and that is going to be indeed because of anthropogenic activities and the climate change, there's increased, you can say, the pressure and reliance on our groundwater, and that is going to be, you can say, this reliance and the pressure on groundwater is going to be more in the coming future. And that's the reason I think the inauguration session, that the title of this FDP is very timely, and that's the need of the day. Now, if we compare both these sources, the surface and the groundwater sources together, the groundwater extends over a very large area. Now, if you drill a well over here in Roorkee, I'm sitting here in the Roorkee, I'll get some groundwater. If you're going to drill a maybe well in the SVNIT, the Surat, NIT Surat, you will also get some groundwater. Maybe guys sitting in the south, that would also get. So, groundwater is largely available. However, it is a matter of the quantity and quality, which type of the quality we are getting, that is different matter. Surface water. Surface water you cannot see. You can't see any surface water river passing through the campus of your NIT. I can't see any stream or the river passing through my IIT campus, Roorkee campus. It is limitedly available. So extension of the groundwater is huge. And that's the reason that when the population is very, very much scattered, in that case, the groundwater reliability is going to be more than the surface water, because the diversion of the surface water to the all individual households or the end users is going to become very costly and infeasible. Availability, indeed, we know that groundwater, you cannot take it easily, because we need energy to bring the groundwater from the subsurface to the surface, and the surface water is available on the surface, so we can always use it. In terms of the temperature, the groundwater has nearly constant temperature. When I say nearly constant temperature, if you look at the seasonal variation, if you go to maybe a lake, you can just go to the winter time, you just put your hand, the temperature is very, very low. But in terms of the groundwater, when you might have seen in the villages, when the tube wells and all these are operating, in that case, you can see the groundwater comes very warm in the winter, and during the summer season, the temperature is quite cool. So groundwater remains at nearly constant temperature, because the impact of diurnal or the seasonal change of the temperature conditions or the climatic conditions are very minimum there. And therefore, most of the industries also rely on the groundwater, because temperature is kept constant throughout the time. The time of residence, indeed, it is going to be quite long, mostly in the groundwater, except the base flow or the very shallow groundwater. So why I'm talking about here the time of residence, because it is time of residence is going to play a very, very important role when we talk about the water quality. So water quality in any system, whether it is in the surface system or in the groundwater system, depends on the time of the residence. More is the time of residence of the water molecules in a system, better is the quality, because the natural microbiota or natural microorganisms are able to revive the groundwater or the surface water quality if the time of residence is more. So in terms of the groundwater, the time of residence is more. I was reading in news in few months ago that there's a well which is found more than 20,000 years in Saudi Arabia. So that is the time of residence. So more is the time. You might have seen sometimes the bottle coming from the Himalaya for the drinking water, and that is costing around 200 to 400 rupees for the, you can say, 250 ml. So the time of residence, that water is going to be more. So more is the time of residence, better is the water quality. Similarly, susceptibility, as I told you, the susceptibility of the surface water resources to the changing climatic condition and the contamination is more. We can easily contaminate a surface water body. You just throw the solid waste or any type of the contaminant near to a water body, it can easily be polluted. However, we cannot pollute the groundwater so easily. So groundwater, the pollutant which are, you can say, thrown at the surface or inserted at the surface, they have to move along with the soil water to the groundwater. And there's a barrier, there's a buffer zone of the bedrock zone. So therefore, the groundwater contamination, the groundwater is polluted. Its remediation, its cleaning is very difficult. And that is why I think I'm very sure the convener of this course has put the term sustainable. So we have to think about the sustainable recharge of the groundwater, not only in terms of the quality, but also in terms of their, not only in quantity, but also in terms of their quality. Okay. Now, quality, if you talk about the more in general, we say that groundwater quality is generally better because why? It is the free from mostly the waterborne pathogenic organisms and the other contaminants, because all these contaminants which are released at the surface, they are filtered out physically, as well as biological activities when the water passes through the soil pores, that are also cleaned up, and we consider that groundwater quality is going to be much better. That is why sometimes we use groundwater directly without any, you can say, the treatment technology or any other devices. Now, there are some issues with the participants. You may feel free to interrupt me. Don't think that it is going to be one way, but whenever you have any question, please interrupt me in between. So if you look at the groundwater, so the problem, so like we are having the problem with the other environmental resources, similarly the groundwater resources is also having the issue. And what are those issues? The first one is the quantity issue. Either the groundwater is depleting or it is coming nearby to the surface. So groundwater depletion or waterlogging conditions, that is related to the quantity. Second issue related to the quality is groundwater salinity. Because we are having the huge water bodies, more than 70% of our planet Earth is covered by the sea, and we know directly we cannot use the seawater because the salinity level goes more than 30,000 to the ppm. So we cannot use. And moreover, this saline groundwater which is there in the sea, not only in the larger oceans, but also in the inland lakes which are highly saline. So they can also contaminate the nearby the groundwater sources. So surrounding to the bank of this water bodies or this sea, the coastal region, the saline water can ingress into the freshwater zone. And once the saline groundwater intrusion is taking place, its revival is very difficult. Why I'm saying it's difficult? Because the density of the saline water is much higher than the freshwater sources. So even we cannot replace this once the saline groundwater intrusion is taking place in the coastal region by recharging mechanisms and all. Now, and then the contamination indeed. So contamination by maybe the agricultural activity or maybe some anthropogenic activity like project-based activities. So or by maybe some municipal activities. So we are polluting the surface water, and that polluted surface water on the soil also allows the movement of this polluted water to go into the groundwater, and that can contaminate our groundwater resources. And we can categorize the different types of the pollutants like NAPL, DNAPL, so that is going to be volatile organic compounds, heavy metals, insecticides, pesticides, or organic contaminants. So organic contaminants are going to be much more notorious in the surface water bodies rather than the groundwater. Now, one of these typical issue with the groundwater sources, if you look at the different types of the problem, is the salinity of the groundwater. It's not only coastal region, but also in the inland area. So total area of high groundwater salinity is going to be 24 million square kilometers in the worldwide. You can see in this map here, all this dark, you can see the red area is having impacted because of the high salinity of groundwater. And this is the 60% of the total land area of our planet that the groundwater is contaminated by high salinity of salt. So salt concentration is high in 16% of the total land area of our planet. The basin in the West and the Central Asia are the largest area with high groundwater salinity. You can see here, these are the very high groundwater salinity area. Now, if you look at the Indian perspectives, 2 lakh square kilometer of India is also impacted by this salt air pollution. So groundwater of this area is having, you can see here, the mostly the central part and the mostly western part of the country here, the saline groundwater you can see here. Similarly, in the Deccan Plateau here, you can see the salinity is going to be more than 1000 of the ppm. 85% of the drinking water supplies and the 60% of the irrigated agriculture requirement are fulfilled by the groundwater. Okay. And if you look at, for example, I'm giving the case example of the Mewat, which is some part of the, you can say, Rajasthan, NCR, as well as the Haryana. 22% of the aquifers of this Mewat, Mewat is a very large area. So 22% of the aquifers are having only the fresh groundwater, and the remaining 78% of the aquifers are containing high salinity. And the salinity is not in the magnitude of the 35,000 ppm of the seawater, but sometimes it goes even 70,000 of the ppm, and that is very high salinity. It can be geogenic sometimes it is anthropogenically derived because of the high precipitation or the other type of the, you can say, the geological formations which are taking place in the subsurface. So this is the recent report of CGWB in 2016. Now, question comes that how to manage our groundwater, which is, I told you that more than 50% is also affected because of the salinity and other contamination. So traditionally what we do, we generally, we need the three systems. The first one is that we need water availability, fresh water availability. The second one is that the media through which we have to recharge that, maybe that is going to be any managed aquifer recharge techniques or any groundwater replenishment techniques. And the third one is the underlying aquifer. So availability of the fresh water, indeed availability is majorly going to come from the precipitation. So we catch the rain and try to divert that into the subsurface through the man-made structures or the modified type of the, you can say, the land use pattern of any area. So these are the some examples where we try to accelerate the natural process of the infiltration by putting some small check dams, or by having some maybe the dune filtration process where the most of the surface water is also utilized for potable water. And most of the like European country have been there in the Netherlands 4.5 years, and like country like Netherlands, Belgium, or even part of the Germany, they use this dune filtration for their potable water rather than going for any chemical treatment and all. Infiltration ponds are also constructed to have more augmenting the groundwater, and also percolation tanks along with the rainwater harvesting tanks. The soil aquifer treatment and underground dams are also provided along the trajectory of the streams where the surface water flow can be hindered, and that can allow the recharge of the groundwater sources. More, you can say the fancy word or technical word, you can say ASR, ASTR, or manage aquifer recharge, aquifer storage and recovery. So aquifer storage and recovery, that is made of the three words that we have to we are having the subsurface geological formation, and that is going to be a reservoir for the fresh water, so aquifer storage, and that reservoir is not going to fulfill its requirement unless it is going to provide the fresh water back to the surface. So recovery and its volume of the fresh water along with the quality of the recovery water which is going to be taken from this recharging structure plays a very important role. And that is what I'm going to come to this one. So in aquifer storage and recovery, what we do, ASR is a managed aquifer recharge techniques, which is used for storing the fresh water in the groundwater in the subsurface horizons during the rainy season. So when the rainwater is available, and it ensures that its recovery is going to take place during the lean season, during the dry season, or during the monsoon period. Of course, the performance of the aquifer storage and the recovery is quantified in terms of the recovery efficiency. And how do we find out the recovery efficiency? Let us say you recharge 1,000 liters of the fresh water by catching the rain, and then you are able to take out 500 liters of the fresh water at the surface. So, remaining 50%, either it is mixed with the underlying groundwater, or it is not able to, or it is going to be going away from the base flow and so. So that is the traditional way of, you can say, the applying this managed aquifer recharge techniques like ASR and all. Now, if we look at these salt affected regions where the groundwater is not fresh water, so we are having in our hand the fresh water sources, and we are targeting the groundwater or aquifers which are there below the surface. Now, in conventional techniques, we don't bother about the groundwater quality, but we are just using recharging the fresh water and taking out during the need. But when your groundwater is contaminated, when your groundwater is having the high salinity, if you go for the traditional way, conventional way of recharging, then what would happen? So when we're going to divert the fresh water into the subsurface, the fresh water is going to make a, you can say the film or a layer of the fresh water over the groundwater table. So this is the, let's say, groundwater table here. And why I'm saying the red color here? Because it is having the high salinity. So when the fresh water is coming here from these drains here or from other recharging structures, so they are stored over the groundwater table in near to the capillary fringe. I'm sure most of you may be knowing about the capillary fringe and all. So this is the zone between the wetter zone and the saturated zone. Now, since the density of this fresh water is low, it is going to remain over the top of the groundwater table as a pancake. Will make a maybe few centimeter depth of the water level or a large area when you recharge it. Now, what would happen when you start taking out this water which has been recharged into the subsurface using and for taking out the water which we use the wells? So when you drill a well or when you are using a well here to extract this fresh water, the cone of depression is generated. And this cone of depression is going to fetch this saline water rather than getting this fresh water. So we were able to target our objective, we were able to fulfill our objective of recharging the fresh water from the rain to the subsurface. However, when it comes for the recovery of this fresh water back at the surface, we are not able to fulfill our requirement. We are not able to take out this fresh water back to the surface. That is because of this mixing of this saline water with the fresh water which has been, you can say, stored over the top of the groundwater table. Not only this physical mixing, but also when a large layer is made, for example, like my tabletop, if you put a layer of maybe mat over the tabletop, so there's a large contact area between a freshwater layer as well as the underlying groundwater sources. So there's going to be always a molecular diffusion taking place from the between these two types of the groundwater sources. And ultimately, because of this dilution or because of this molecular diffusion, this fresh water is also converted into the saline water. So whatever the investment we have done over this rainwater harvesting as well as the recharging structure, that is going to be going in the van. So we are not able to recover the fresh water. So how to develop a modified, you can say, how to go for a better framework of the managed aquifer recharge, where we can also make sure that most of the recovery of the fresh water at the surface is possible. Now, if we look at this MAR technique into the confined aquifer, you can argue that, okay, why do we then target this unconfined aquifer? Let us go for the confined aquifer. Indeed, many confined aquifer are also having this salinity issue, and their salinity is quite high. So if you go for the recharging well, which are tapping into the confined aquifer, so we can tap them and we can recharge the groundwater through this injection well here. So because of the high hydrostatic pressure which is provided because of this distance from the surface to the confined aquifer, water will be able to be stored into the confined aquifer. And this is going to be a buffer zone which is going to be made. Or buffer zone here, it is the mixing between the stored fresh water. So one side of this buffer zone is the fresh water which is injected from this well, and other side is going to be a, you can say, let's say, polluted groundwater or maybe saline water. And that is how it is going to made. Now, if we look at it in a more detailed way, so what we do have in ASR setup, which is generally have a injection well. So this is the center of this well is nothing but your injection well, where the fresh water is diverted from the surface, and the water is stored here. You can see this is the water storage. You can say that this is a bulb of the fresh water. You can say the zone, and then we are having either you can take out this fresh water from this same injection well, or we can have a series of the extraction well near to this injection well, and their depth can also be varied. They may be at different depths of the aquifer, and you can see this is going to be the interface between the saline and the fresh water when we inject this like this system. But the another way of making this one, if you inject the fresh water at the near to the, let's say, the upper impervious barrier. So if a zone of this shape is going to be made, where it is going to have more area over the top, and you can say this is going to decrease exponentially when you go into the deeper confined aquifer. And if it is not sufficient amount, or if it is even more shallow depth, the release depth, in that case, it is going to make a bulb of fresh water, something like that. Now we have implemented this this type of this modified framework into salt affected region of this Mewar. So the phase 1 is going to be injection phase. So injection phase is going to be the time when we are having the surface water availability, and you know that when do we have the surface water? During the rainy time. So this is the entire year, Julian year. You can see here, during this Julian year, you can see this is the rainfall event. So this is the phase where we are having plenty of the fresh water available at the surface for recharging. So this is going to be a recharging phase for our ASR technique. And the second one is going to be storage phase. So after the injection of the fresh water, we do have the storage phase, because we don't need any fresh water here, because it is just after the monsoon period, and most of the surface water reservoirs, most of the soil moisture content is at a high level. So immediately after the storage, we don't demand the fresh water. So that is why we call it as a storage phase, the second phase. And later on, during this pre-monsoon period, mostly, that is noted by number 3 here, is the recovery phase, when we need most, because there is no surface water available, no rain, so we rely mostly on the groundwater, and most of the surface water reservoirs are also depleted. So this is going to be recovery phase. So our objective must be targeting to this recovery phase, so that during this recovery phase, we must have the availability of this fresh water zone which is there. If we allow, or if you can inject at a optimal depth of the aquifer, then the efforts should be made that the availability of the fresh water in the subsurface is high during this period of the year. And that is a one cycle. Then again we wait for the next year, and then go for the injection phase during the monsoon season, followed by the storage and the recovery phase. That is what we call cycle 1, cycle 2, and so on. Now question comes that how to go for this improved managed aquifer recharge framework, where the salinity is the issue in the groundwater. And to understand that one, we have to look into the different types of the factors which are going to affect this recovery efficiency of the fresh water which we have injected into the subsurface. So there is a number of the factors which can affect this recovery efficiency of the managed aquifer recharge water. And amongst them, that where to establish the ASR scheme. The first one is to identify a suitable location. Suitable location, because we may be having a region, maybe in terms of the state, in terms of a maybe district, in terms of a watershed, a microcatchment. So first we have to identify the place where to implement this improved managed aquifer recharge technique. And then how to design the ASR well. Do we need a single well, injection well and extraction well, or we need a maybe a network of the injection as well as the extraction well with their depth, whether it is going to be constant depth or variable depth. So that is going to be for designing of the extraction and the injection well. And how to operate ASR scheme. Operation here means what should be our injection rate. Is it going to be slow? It is going to be high. And what should be our extraction rate? What should be the depth of the extraction? So that all comes under the operation scheme of this ASR. And indeed, whatever the kind of the saline groundwater, what is the fluid properties, what is the difference between the freshwater density and the underlying groundwater, saline groundwater density, that also need to be taken into account to understand the interaction of this freshwater with the surrounding saline groundwater. So these are the things which we need to answer whenever we go for this type of the advanced managed aquifer recharge techniques. So these are the some factors which we have investigated in general for arid and semi-arid region. Why I am calling arid and semi-arid region? Because most of the part in arid and semi-arid region, this salinity of the groundwater is a major issue. So we have checked this recovery efficiency, for example, longitudinal dispersity. I don't know how many of you are aware about the dispersity beyond. So whenever the water soil solute or the contaminants move through the soil, the dispersivity, hydrodynamic dispersion coefficient plays very, very important role for the contaminant freight and transport. So how this longitudinal dispersivity, the density of the saline groundwater, hydraulic conductivity, you must be knowing that how water easily flows into the aquifer mass. So hydraulic conductivity, as well as the volume of the injected water. So maybe you are having a rainwater harvesting and discharging technique, then what should be the volume of the water that should be diverted into the subsurface? So that volume also needs to be optimized. If it is a very, very small volume, then maybe your recovery efficiency is going to be very poor. But when your large volume is there, neither we have the infrastructure, nor we have the availability of the fresh water for us for recharging the groundwater resources. Similarly, the duration for the storage, maybe in Roorkee, I need most of the fresh water during the month of the May or June. Maybe in the Kerala, people need it not in the June, but maybe in April or the May. So depending on the storage, so depending on our requirement of the fresh water, we also plan this storage duration for this water which has been stored in the subsurface, and indeed the hydraulic gradient. So those are the very crucial factors which needs to be investigated for a particular site before we plan for this type of the improved, you can say, manage aquifer recharge techniques for sustainable development of the groundwater resources. Now, in nutshell, I'm summarizing all these parameters or the factors which can affect this aquifer recharge and the recovery. The first one is the planning. Planning, during the planning phase, we have to see, the first question in our mind comes, whether do we have the fresh water availability? If yes, what are the sources? Whether it is coming from the rain, whether we are going to use it as rain, the river water, or any other source of the fresh water. So the river water, storm or rainwater, or maybe some treated wastewater or seawater. So all these are going to be the source for the recharge of the water. So that should be evaluated during the planning of this managed aquifer recharge technique. And then potential usage of the recovered water. The second question comes in the mind, that why do we go for this managed aquifer recharge? Are we really need the fresh water in the lean season? If yes, then how much we need for the potable, how much we need for the domestic, how much it is needed for industry and the agriculture sector. And indeed, the requirement is going to be different with progression of the time. After planning the site and after evaluating the available resources and our target, you can say the area, this target usage of the water, we have to look at the geology, especially the aquifer characteristics. That is what I call aquifer hydrogeological factors. Or you simply say the aquifer characteristics or hydrogeological conditions. Why do we need? Because this is in your hand, surface water, which you are, or maybe utilization of water, that is going to be in our hand. We can evaluate that one. And this surface water has to pass through the structure, subsurface structure that is made of the aquifer. That is going to be a receiving reservoir. So we have to see that whatever the receiving environment of this fresh water is going to be there, how it is going to interact, how it is going to behave with the water which is coming from the top. So all the hydraulic conductivity, porosity, gradient, aquifer thickness, aquifer heterogeneity, hydrodynamic dispersivity, and groundwater salinity, level of the groundwater salinity, all this needs to be investigated to see the influence of the site selection, especially for the application of this managed aquifer recharge in salt affected region. Now, after investigating the subsurface hydrologs, we have to go for the designing of the wells. Maybe we need a number of injection well or a single injection well, or the depth, what should be the depth of the injection well, or maybe the extraction wells, a number of the extraction wells. So network of the injection as well as the extraction well needs to be designed, not only their number, not only their network, but also their independent, you can say, design. That also, like ASR well setup and their clogging and the plugging issues needs to be addressed during this design step of this ASR. And finally, once you are ready with your managed aquifer recharge, then we have to go for the operation. So how to implement that one? So for implementation point of view, we need to optimize the rate of injection. What should be the rate of diversion of the surface water? Indeed, sometimes we have plenty of the surface water and we cannot divert it. So what should be the optimal rate of injection? If you are targeting a high rate, indeed, your cost involvement for making the structure of this managed aquifer recharge is going to be huge. So depending on the kind of, you can say, the availability and kind of the resources which are available and the kind of the requirement of the fresh water, we go for a particular structure. So rate of injection is going to be play a role. Injected freshwater volume. So what is going to be the total volume throughout the year? We can target, okay, during the 3 years of the maybe monsoon period, we can inject this X volume of the freshwater into the subsurface, and based on that one, we can also calculate the rate of injection, optimal rate of injection. And then storage duration. What should be our duration? Whether it is going to be remain at the 6 months in the subsurface before it to be utilized, or it is going to be for a shorter period. Sometimes we go for a shorter period, sometimes it is going to be for the annual, you can say, cycle point of view. So depending on our requirement, depending on our objective, the storage duration has to be taken into account for the successful, you can say, the operation of this managed aquifer recharge. And then successive ASR cycle. How many cycles? Is it going to be yearly or it is going to be monthly? Depending on our availability and depending on our utilization of the freshwater resources. So to check those parameters, we conducted very, you can say, controlled experiments in the laboratory using the large sand column experiment to create a scenario of the subsurface. So you can see this is a large vertical sand column, okay, representing a saline groundwater. So saline groundwater is filled here and injected the freshwater here. One can inject from the top also by drilling a well here, but just for the easy implementation of this project, so we allowed the water through a peristaltic pump at the bottom of this pump here. So you can see this is a freshwater zone. How it is made? Because the water is applied at the pressure. And when in the natural condition, how this pressure is coming? Because of the hydrostatic pressure. So freshwater zone is built. Now we know the density of this freshwater is low and density of the overlying saline groundwater is high. So the water which is lighter in the density needs to come upward direction because of the buoyancy force. So what of this freshwater started coming up, moving started towards the subsurface. And if you are able to capture this freshwater plume during its ultimate mixing or during its coming up at the water table, we can achieve a higher, you can say, recovery efficiency. So one has to investigate, consider the kind of the aquifer material, its characteristics for, you can say, the optimal recovery of the freshwater. Optimal means highest recovery of the freshwater which has been injected here. So we did these experiments under controlled condition and then measured this salinity timely at all these sampling ports. So sensors were applied and we measured the electrical conductivity of the saline water, and it started decreasing when this freshwater started coming up towards against the gravitational force. So these are some breakthrough curves. I'm not going to go in the nitty-gritty of all these breakthrough curves. And then after conducting this one-dimensional column experiment, we upscaled it to the 3-dimensional, because in the field we cannot rely only the one dimension that is going to be vertical flow, but it is going to be in the aquifer. It can be happening in the unconfined aquifer in all the direction. So in that case, we have taken these tank experiments, 3D tank experiments, having the different sampling ports at different depths, as well as the length and width of this tank setup. And we have taken an injection well here, supplied the fresh water again through the peristaltic pump, because we could not create here more hydrostatic pressure, which we can get in the real field condition. And then again saw the micro. And those are the some snapshots of the, you can say, the findings which we obtained from these 3-dimensional tank experimental analysis. You can see here, that is, I think, more easily visual here. So you can see here, that is after injection. So when we took the injection location at the surface, that is how your fresh and the saline groundwater is looking. So this bluish part is going to be fresh water, and then you can say diffusion zone. Why it is diffusion zone? Because we know the contaminants move from the higher to low concentration. For example, if I open a bottle of the perfume here in my room here, the guy sitting in the corner of my room can also smell. Why it is so? Because the solute or the pollutant goes from high concentration to low concentration. Similarly here, the salt molecules which are here, they are moving towards this fresh water, and that is why there is a zone of diffusion. There is no sharp interface here. Okay. Now, if I keep my injection depth somewhere here, that is how my shape of my fresh water bulb is going to be developed like that. And if you go further deeper, you can see a face, the shape like that. And you may get a different type of this shape and size of this plume depending on the kind of the aquifer material. If your aquifer material is different than what we have taken in this experiment you can have a different type of the shape and size of this plume. And this is how this plume is behaving with progression of the time. For example, when we injected at the top, so it is started spreading. Now see, the contaminants, I mean the volume of the water available just after the injection was largest, and then later on it decreases. You can see the bluish part is going to be less, and it is going to become more lesser, and almost disappeared here. Because we have extracted it after 4 hours, whatever the little amount is left. And this is why I'm showing in the hours. You can argue me with me that it's going to be in days, but it is a very, very small scale. Okay, when you go for the field, indeed it can be in months or weeks, or it can be in maybe the quarter or the half yearly of the time scale. So same type of the trajectory, you can see that how it is behaving. So those practical experiments which looks little simple here, but they give a very, very important crucial information when you go for the application of the groundwater recharging. You can say the application groundwater recharge structure in the field, particularly where the saline groundwater is there. Something which we got from these experiments, one-dimensional and multi-dimensional experimental setup, we are applying this now in the Kerala, in the coastal region of the Kerala. So a couple of projects as mentioned by Ayushi and the other girl, that we are having 2 projects, which one is sponsored by DST, another project from the Netherlands government. So we are doing these projects in the 4 project sites are there, one in Rajasthan, one in Odisha, and one in Kerala, and one in Mewa. So we are looking at the different scenarios of the geological formation. So there may be different geochemical factors, as well as this coastal salinity, the impact of the confined and unconfined formations. All these are investigated in the field as well as in the practical laboratory. Now before going into the field, we have also predicted this through the modeling, because we have done the experiment in the lab, and that is at a smaller scale. And in the field or aquifer, our availability of the rainwater and everything is huge. So how to go? We cannot do such type of trial in the field, because the cost involvement in the field experiment is going to be more than also the time requirement. So before going for the real experiment, we have also conducted some numerical runs using the mode flow and the associated SVNIT model for looking at the behavior of this freshwater surrounding saline groundwater. And based on these model outcomes and the practical experiment which we obtained, we applied this one into the field. And these are some modeling results which we got from this numerical experiments here. That is very large scale, you can see. So this is the going in kilometers here. So you can see that when you have a set of the pumping well, the center of that one, and the 2 wells, well number 2 and well 3 are the extraction well. So you can see the isomers here. So these are the concentration, equal concentration line joining here. So this is your freshwater pocket. Why it is wide here? Because when you inject it, the freshwater started coming up here at the top. So that is why the top of this plume is going to be more wider than as compared to the narrow. You can see the deeper zone. And then you can see this is going to be diffusion zone, where the concentration here salinity is 2000 ppm, 5000, 8000. And we took 14,000 of the ppm. It's very high indeed. So 14,000 to 500 of the ppm of the, you can see the salinity is, you can see that we took this high salinity here just to see the contrast of this one. One can take the real salinity which is there in the field. If it is not 14,000 ppm, one can go for the maybe 2,000, or if it is more, so one can select the real field conditions which are there into the you can see the aquifer system. And then this is your injection phase. You can see here the picture number 1, and then the bottom picture, the middle picture, you can see this is the storage period. So during the injection, mostly the fresh water is expanding. The zone of the fresh waters keep expanding, along with of course some rate of the mixing and dilution. But later on during this storage phase, and that is what is the pre-monsoon period. So little bit only this, you can say, the molecular diffusion is taking place, and the volume of the fresh water started decreasing here. And then the recovery phase also plays very, very important role. You cannot use one pump. Otherwise, if you are going to use one pump, maybe recovery efficiency less. So one has to go for a multiple options depending on the shape and size of this bulb which has been created here. When I say the freshwater bulb, it is not a small area, but it is a huge region. Okay. So the multiple, this set of the recovery well is going to be sometimes useful for getting the high recovery efficiency of this freshwater. These are some findings. Let's say the first one is going to be the recovery efficiency in terms of the storage volume. So when your storage volume is small, recovery efficiency is not so high. Let's say 20% or 25%. But when you increases the volume of the water which we charge, recovery efficiency keeps increasing almost, you can say, linearly, and then asymptotically it is reaching a constant value. It means if you recharge a volume beyond this volume here, that is not going to have the impact of our recovery. So we can take a decision in the field, okay, the minimum volume of the water which is going to have, this is going to be have the highest recovery. This tell about the injection and recovery rates, what is the rate of the injection or the extraction rate has been taken. So one is going to be for these multiple wells. Red line is showing the single well system here. So both of the system are showing the different recovery efficiency depending on the injection and the recovery rate, which we have taken here on the x-axis. The third diagram here is showing the recovery efficiency with the ASR cycle. This is the cycle number 1. So cycle number means the first year when you injected and then you recovered. The recovery efficiency was not so great. It is around 10 to 20% here, you can see. But for the next year, most of the things are more, you can say, stable, and already the fresh water is retained from the first cycle, and that's the reason that recovery efficiency has increased here tremendously. And that makes over the first similar values not so significant, you can say, increase into the recovery efficiency. Storage duration, of course, very, very important, you can say. So storage duration, of course, when you increase the duration of the storage, recovery efficiency started decreasing. So we have seen it for the 120 days, but it is going to be interesting to see even more longer duration. If you go more duration, maybe the recovery efficiency can dip very sharp. So that we have to investigate in the field. The impact of the temperature. So maybe the how the temperature of the fresh water which we are injecting and what the temperature of the saline groundwater, this contrasting two temperature can also play a very important role when it comes for the dilution of the molecular diffusion of the fresh water and the saline water, underlying fresh water, saline water resources. And the last slide, that is going to conclude. So the performance of the managed aquifer recharge, or you can say the groundwater recharging structure in saline groundwater region, depends on the aquifer properties, operational factors, well design and the network. When I say the well design here, it is going to be pumping or the recovery well. And indeed the mixing phenomena, mixing in how the mechanical mixing or the molecular diffusion and the fluid properties, means the density difference between the saline and the fresh water. All these are going to play very, very important role. And one must characterize the site. Site means characterization. Site means the aquifer properties, the kind of the level of the, you can say, the salinity or any other type of the maybe the acid, other water quality parameters. They also indeed play very, very crucial role when it comes for the diffusion and the mixing of the fresh water with the saline water. The second conclusion what we drawn here, the recovery efficiency of the stored fresh water within the saline aquifer can be increased by identifying a suitable location for the ASR scheme. So geophysical investigation, a very, very important role when we have to go for a successful, you can say, when I say successful MAR, it means we have to target a high recovery efficiency. Effective ASR well designed and optimized operational management are no doubt necessary for the effective utilization of the ASR. Multiple partially penetrating well types ASR wells are found very efficient as compared to the single fully penetrating. Why I'm saying as compared to the single penetrating? Because the cone of depression from a single fully penetrating wells is very, very magnificent. And mechanical dispersion because of this cone of depression is going to be very significant, and that may allow the saline water come at the surface very quickly by bypassing the fresh water sources. So one has to go for the multiple partially penetrating well if you want to go for the high recovery efficiency. Optimization of the operational factors using the numerical modeling plays very important role by applying your practical findings from the laboratory or pilot scale study to a larger scale, and that is what we are doing now in the field. And with this one, I am sure I have taken the exactly 8:13 or 8:50 1 hour what Professor Sanjay has instructed me in the initially. So thank you all. Thank you very much for your listening. And I'm coming back to the stop sharing mode.
Thank you, sir.
Yeah.
Sir, there is a question. When salinity is spoken, does it refers to NaCl only or but TDS which may contain other salts also? This is by Karan.
Any salt current. Current, when I talk about the salinity, I'm talking about all the chlorides, all sodium, calcium chlorides, whatever the salinity, TDS is comprised of, that is coming from all these anions, major chlorides. Yes. In fact, one can consider not only the salinity but also the other type of the pollutant which are not shown here. So one can also consider the other solutes which are going to pollute the subsurface water. That can also be considered here. But then one has to take the density into account. So density of the polluted groundwater or density of the saline groundwater is going to play a role when it comes for the dynamism of the fresh and the saline water.
Sir, the next question is from Dr. Kruti. She is asking that, sir, if you have some small video of experiments, please show to us.
It is not right now ready-made with me, but yeah, I can. Yeah, there's a good question, and I can share it with the participants later on. You have still 2 weeks of the time, and I will try to share the video of some experimental setup and the practical experiment which we have conducted in the field.
Participants, if you have any other question, you can unmute yourself and directly ask. Dr. Reena, ma'am.
Sir, you have talked about how to find out location of aquifer storage recovery well. So for geological investigation, some GIS technique is used, or what is used for that?
Yeah, see, identification of the site, recharge site is very, or you can say that's the first step when you go for any managed aquifer recharge techniques. So GIS and remote sensing, indeed, they can give you a rough idea. Rough idea here means they can give you an approximate idea of a larger area. Okay. Let's say you are having a very large area, and use of remote sensing and GIS can help you in identifying some probable position. But when you're going to implement that in field, the complementary, or you can say more site-specific geophysical investigation, for example, vertical electrical sounding, ERT system, electrical resistivity tomography. So those plays very important role where we can map the entire subsurface. Why do we are concerned about the subsurface? Because whatever the water which we are recharging from the surface has to pass through these lithologs, and we can predict the quantity of not only the quantity, the quality as well, that what is going to be the water quantity or quality to the groundwater table, or maybe the recharge location where we are targeting. So this is the geophysical, a set of geophysical investigations are generally we use for identifying the site in a given possible location.
Thank you, sir.
Dr. Reena and Dr. Brijesh, we have one session right from 9 o'clock to 12:30 p.m. on 15/12/2022, where we will be actually performing geological investigation to find out a recharge location near our civil engineering department. So this exercise is already been framed in our offline schedule.
I have seen it. I think, yes, I see that program, and it is meticulously planned. And I think that would also answer many other questions as well. Yeah.
Okay, thank you, sir.
Sir, there is one more question. What are the main criteria to check quantity and management of open well, dug well water supply which supplied in village or district?
What are the main criteria to check the quantity and management of open well, dug well water supply? Yeah, which supplied in the village districts. check the quantity. I could not understand, Urusi, what you want to ask. Main criteria to check the quantity. Are you talking about the quality or quantity here? Probably, maybe you are writing about the quality, right?
Urvish, are you here? You can unmute and ask. Yes, sir. He's saying yes,
Okay,
sir.
he's saying yes. Yes, so quality is important because we cannot divert the water to the surface water which we collect during the rainwater. Indeed, sometimes we go for the pre-treatment, and some people also, advocate about use of the treated wastewater. Water quality of the recharging water is very, very important. One has to go not only the conventional water quality parameters, when I say the conventional, major anions and cations, but also the emerging pollutants. Sometimes you cannot see those emerging pollutants in your conventional testing. So those needs to be investigated before we use such type of the treated water. If it is coming from rain, of course, we don't expect much type of the emerging contaminant from rainwater. But the treated test water, which we are sometimes getting from the industry or other municipal sources, that needs to be well tested before we go for the augmentation. Because there are many elements which are, you can say, analytical equipment, they cannot detect. There are emerging contaminants, even in trace elements, they can be hazardous for a longer time and they can pollute our groundwater sources also. So one has to be very, very careful. That's a very good question. That quality check of the recharging water is very important, because once the groundwater is polluted, I told you, its remediation is very difficult. If your surface water is polluted, of course we can go for a easily in situ treatment of this surface water. But groundwater, because contaminants are get absorbed by the soil matrix, and removal of these contaminants from the subsurface is a very tedious zone, and that is why we call that remediation of groundwater is much difficult as compared to the other surface water sources.
Sir, we'll take last quick question. That column test is considered in leachate penetration.
Yeah,
For
it can
leachate
be.
management,
Yes.
please
Yeah, one can
leachate
go.
management, please give brief idea.
Yeah, one can go for that one, because Saurabh, it is a nice question, because sometimes you go for the dump side or maybe landfill site where the leachate is collected near to that one or maybe below to the liner. So in that case, that leads to the weather zone. So for testing the fate and transport of these leachate through the soil, one can go for this practical experiment and can check that how these all these contaminants which are there in the leachate are going to behave, how their fate and transport is happening into the subsurface. That can always be tested in the column experiments. But column experiment will give you the moment behavior of this contaminant. It is not necessary it is going to be treat the your leachate. Okay. So one has to go for the maybe some treatment technique by dilution of the leachate, or maybe some aggressive treatment techniques which can be used for that cleaning of the leachate which is generated from the MSW.
Thank you so much.
So thank you very much, sir. Good questions. Saurabh, you want to ask anything?
No, sir. No, sir. Thank you, sir.
Okay. So thank you very much, sir, for sparing your valuable time and giving in-depth insight, in fact, to all the participants. I think participants are benefited by it, and definitely they will carry some of this kind of work at their institute. Thank you very much, sir.
Thank you so much. Thank you.
So participants will have a quick break of 2 minutes, and we will start with the next session where I have to deliver a lecture. So just a 2-minute break.
In case if they, Sanjay sir, in case they have more questions, they can also send me. I'm just sending them by email. So in case if they have questions later on,
yes,
they
sir.
can
That will be wonderful. Wonderful.
Okay. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Am I audible? Hello.
Yes, sir.
Yes, sir.
Is my screen visible?
Yes, sir.
Good evening, everyone. Basically, I'm going to discuss about methods of groundwater recharge using rooftop rainwater harvesting. This is the presentation which I'm going to share with you, and I'm happy that you can use this presentation for properly citing this article. When we talk of water, what is water? So we can say water is one of the most pressing challenges facing the world. One side you will see one picture in which there is a situation like drought, and the other situation where you will find it's a flooding. Right now, the Brazil, part of the Brazil is suffering due to heavy flood, while the Somalia is facing successive drought since last 2 to 3 years. This is the iconic picture probably some of you might have seen on social media, where you find that the bodies of 6 giraffe lie on the outskirts of Ivory village in Saubali Wildlife Conservancy. This is a picture from Kenya's drought in 2021, where not only the giraffes, but if you will see here, these women, they are just trying to get drop of water from the riverbed, which they were collecting, for which they walked miles. Not only they walked miles, but if you can see here, the quality of water which is in this bottle, and the woman is drinking that particular water. It is said that the quality of water is such that the water can cause stomach problems. So this is very recently, this is the pictures from Kenya's drought 2021. You may say, sir, you are talking about Kenya, you are talking about the world. What about our India? So if we talk about the very close part in South Gujarat, that is the Dang district or Dang area. This Dang area receives average annual rainfall of 1900 mm, 1900 mm. But during the summer season, the people of this region starve for drinking water. And this is in the news, where a man who tried to ask help from the authority and from the sarpanch, but he didn't find it working. Then he himself dug a well in the Dang district of state of Gujarat, and this has happened in June 27, 2022. So across the globe and very close to city of Surat or district of Surat, the stress, water stress is felt everywhere. When we talk about the water demand, availability and extreme events, global water demand for all uses presently about 4,600 cubic kilometer cube per year. That will increase by 20 to 30% by 2050, up to 5,500 to 6,000 kilometer cube per year. Global water demand for agriculture will increase by 60% by 2025. The global water cycle is intensifying due to climate change, with wetter regions generally become wetter and drier regions becoming even drier. The UN water report says that at present, the current trends persist. Billions of children and families will be left without critical life-saving water, sanitation and health services by 2030. Only 81% of the world's population will have access to safe drinking water at home, leaving 1.6 billion without it. If we talk about India, as per the report of Niti Aayog, India may face the worst water crisis in its history, and 21 Indian cities will run out of groundwater in near future. 40% of Indians will have no access to drinking water by 2030. That's what Niti Aayog report says. In 2015 and 16, 15-16, 14 of the 24 states analyzed scored below 50% on water management. Gujarat performed best with score of 76%, followed by Madhya Pradesh, Andhra Pradesh, and that of the Karnataka. If we talk about the water scarcity and the shortage of water, it's history that on 19 June 2019, Chennai city officials declared that day zero, or the day when almost no water has left, had been reached, as all of the 4 main reservoirs supplying water to the city had run dry. This is a picture of 2018. This is a picture of 2019. The successive droughts of 3 years, 2 years of deficient monsoon rainfall, particularly in 2017 and 2018, had led to this crisis. Probably you have read into the newspaper that the water was sold in Chennai. Not only that, the special trains were run. There were certain shopkeepers who used to sell along with idli the 1 liter of water free. That type of scheme has been brought out by the shopkeepers in the city of Chennai in the month of June 2019. Water demand cannot exceed the water availability. While water demand is increasing, water availability is shrinking. In the 2010s, groundwater use globally amounted to 800 km³ per year. India, the United States, China, Iran, and Pakistan accounted for 67% of the global extraction. More than 30% of the world's largest groundwater systems are now in distress. The simple message is that water resources will decrease dramatically by 2050. We see here the simple message is that water resources will decrease dramatically by 2050. And the same time, the water quality, at present, 12% of the world's population drinks water from unimproved and unsafe sources. More than 30% of the global biodiversity has been lost because of the degradation of the freshwater ecosystems due to the pollution of water resources and aquatic ecosystems. Water quality by 2050. What are future challenges? The demand for water will increase by 2050, but the availability of water will be reduced. Water resources will reduce. Pollution will further reduce the amount of clean fresh water. This is the map which shows depth to water level map post monsoon 2018, and you will find that the red areas where the depth of water is more than that of 40 meters, right, in certain pockets of the country. What is the solution? The solution is recharging. When we talk of recharging, what is recharging? Artificial recharge to groundwater is defined as the recharge that occurs when the natural pattern of recharge is deliberately modified to increase recharge. The process of recharge itself is not artificial. Though the word used is artificial, it is not an artificial recharge. It is only a natural pattern of rechange, which is deliberately modified to increase the recharge. The same physical laws governs recharge, whether it occurs under natural or artificial conditions. What is artificial is the availability of water supply at a particular location and at a particular time. Artificial recharge, in the broad sense, one can define as any procedure which introduces water in a pervious stratum. You'll see the picture on the right hand side. This is a real picture which is taken from website of Pani Foundation. Probably the participants from Maharashtra may be knowing this is the area of Vidar, which is a water stress area. People are not used to have water for successive years, and the Pani Foundation has carried out number of ponds which stores the water, and that has sufficed the requirement of water. That has entirely changed the life of people of this particular region. When we talk of artificial recharge, what are the artificial recharge methods? A variety of methods have been developed for recharging the groundwater artificially. The most wisely spread methods can be described by types of water spreading, releasing water over the ground surface in order to increase the quantity of water infiltrating into the ground and then percolating to the water table. Although the field studies have shown that many factors govern the rate at which water will enter the soil. From a quantitative standpoint, area of recharge and length of time is in contact with soil are most important factors for which affects the artificial recharge. When we talk of recharge systems, this is the picture or image which nicely describes about the recharge systems. The recharge system can have surface system, which is surface basin. It may have excavated trenches, that is P. It may be have excavated basin, then it may have an excavated trench, which is shown in figure C. It have shafts, which is excavated up to Vadose zone, and the bore wells, which are having a depth in terms of meters. The artificial recharge techniques can be classified into two categories. One, direct surface techniques. Another one, direct subsurface techniques. And third one, combination of both, that is surface technique and subsurface techniques. When we talk of direct surface techniques, the direct surface techniques include flooding, basins or percolation tanks, stream augmentation, ditch and furrow system, over irrigation. While direct subsurface techniques includes injection wells or recharge wells, recharge pits and shafts, dug well recharge, borehole flooding, natural openings. So the techniques which we are going to discuss, the methods which we are going to discuss in this presentation from roof water are direct subsurface techniques. And in the succeeding slides, we'll be one by one see all these techniques with which we can recharge the groundwater. The indirect techniques includes induced recharge from surface water sources and aquifer modification. Let us talk about the direct surface technique. So first and foremost, a simple technique of recharge is flooding. Flat region where water can be sprayed as a thin layer. Water is distributed over the region using a distribution system, and this method can achieve higher rate of infiltration in a region having thin vegetation cover or sand soil cover. The second method is stream augmentation method. Seepage from natural streams or river is artificially increased by putting some series of check dams across the river or stream. The placing of check dams spread the water in a larger area, which eventually results into the recharging of groundwater. Ditches. A ditch is described as a long, narrow trench with its bottom width less than its depth. A ditch system is designed to suit topography and geological condition that exists at the given site. A layout for a ditch and flooding recharge project could include a series of trenches running down the topographic slope as shown in this figure, and that will lead into the recharging of the groundwater. When it comes to direct subsurface technique, which we are going to see in detail in succeeding slides, the recharge valves. In areas where the aquifers are overlain by considerable thickness of impervious formation, a new recharge tube well can be constructed for recharging the harvested rainwater. This is the planning of artificial recharge projects. You can see that the surface as well as the subsurface stratum and the geography, which explains how the pumping wells, the water is pumping wells, at the same time the recharge wells, the recharge locations from where the water can infiltrate into the ground. Rainwater harvesting is the simple process used to conserve rainwater by collecting, storing, conveying, and purifying for later use. Rainwater harvesting is one of the simplest and oldest method of self-supply of water for households and residential and household scale projects, usually financed by the users. This is the what you can say definition sketch of rooftop rainwater harvesting scheme, in which you can see that the catchment area is the rooftop, which can be carried by the pipe either into a rainwater storage tank, and from rainwater storage tank via filter it can be taken into the underground sump. This underground sump, the water may be again pumped and can be used for the household purpose. The components of rainwater harvesting system, which I am showing over here, that is collection area, roof, that is gutter, which is collects the water which is falling on the roof, which will be carried through the pipe system, either overhead in a storage tank, or you can see over here underground tank or underground storage tank, and from which it can further either discharge or recharge into the duct well. Why I am showing this particular system to you? The reason is that we are going to design the rainwater harvesting system in our offline class. And in our offline class, we will try to find it out, not only the recharge rate, the size of the tank, the size of the pipe, as well as the cost of underground tank, which is required to store some amount of water. So this figure which you see, this picture which you see, each and every component of this, that will be designing on for 13, 14, 12, 22 in our afternoon session, 2 p.m. onwards. What are the various methods of rainwater harvesting? So rainwater can be harvested from rooftop, that is rooftop rainwater harvesting, campus RWH other than that of the roof area, stormwater harvesting and defunct borewell recharge, defunct quarry mines water use. This defunct borewell recharge, we have arranged one practical session of 2 hours where we will try to find out whether the bore can be used for the purpose of recharge or not. And that exercise we will perform, I think it's on 15th of December in the morning session, 9:30 to 12 o'clock, wherein we will actually apply water into a bore and we will check that whether that bore is capable of recharging or not. Restoration and regeneration of water bodies, these are some of the methods of rainwater harvesting, not the rooftop rainwater harvesting. The rainwater can be harvested in any of these methods which are listed over here. Apart from that, the other methods which are used for the storage or conservation of water. Let us talk about rooftop rainwater harvesting. The roof becomes the catchment and the rainwater is collected from the roof of the house building. The storage tank suitably located underground or on the ground for direct use or groundwater recharging. The runoff collected from the rooftop can be efficiently used for artificial recharge of groundwater, especially in urban areas. The areas having depth of water table greater than 8 meters below ground level and underlined by permeable strata are suitable for artificial recharge. All of you, please note this fact that the areas having depth of water table greater than 8 meters below ground level, approximately 7 to 7.5 meters below ground level, then we can go for recharging, artificial recharging of the groundwater. Here, someone may ask me a question, sir, is it required that the depth should be greater than or water table should be below 8 meters? If the water table is just at 2 meters below the ground, can we not able to recharge? No, we cannot. And we have specifically, this problem has come as a consultancy work to me, wherein the people in the Hazira region, Hazira is the coastal area and hardly half a kilometer away from the sea, where they want to do artificial recharging of groundwater, but the water table is just below the 2 meters, and hence there they have to think of some another technique, or maybe the injection, deep valve injection into the groundwater may work as a, what you can say, recharging technique. So the areas having depth of water table greater than 8 meters below ground level, they are suitable for what you can say rainwater harvesting. The most suitable recharge structures for rooftop rainwater harvesting are recharge pits, recharge trenches, recharge through dry or operational dug wells, recharge through abandoned wells, and recharge wells. So these are the techniques which are used to divert rooftop rainwater directly into any of these for recharging of the groundwater. I'll show you the first one, wherein the rooftop rainwater is harvested into the existing active bore. I'm saying it is harvested into existing active bore. Instead of explaining you through slides, I'd like to show you the video of it, that how the rooftop water can be directly recharged into existing bore. I think you are not able to see my video. Are you able to see? Hello?
Yes, sir.
You can see my video?
Yes,
Yes,
sir.
sir.
Okay, okay, fine, fine. Just to explain you it in English, in this, yeah, so yeah, you can see here, this is the outlet of rooftop, and with the outlet of rooftop, this plastic is tied. The rainwater which is falling on the roof through this outlet and via this pipe get into the drum. The drum is filled with coarser and finer material which acts as a filter. So the rainwater after first rain get diverted through this pipe into the drum. The drum have filter media, and from this filter media the pipe is taken to the nearby bore, and water is diverted from drum which is filters through the filter media, and then it reaches to the groundwater. In this case, the water is directly recharged into the bore well. The person is saying that he is following this practice since last 3 years, and because of that he is benefited that at least after monsoon season for 3 months he get good quality and quantity of water. So once again I will show you as I have explained it in English, so those who have not followed the Gujarati can watch again this video. So this is the drum which he has made, and in which he has made the filter media. So from this filter media at the bottom, as you can see here is the bottom, approximately 30 centimeter of the sand and boulder is filled into this particular drum. So rainwater after passing through this filter medium, it comes out as an outlet. See here, the pipe, the outlet from the filter that has been directly taken into the bore, and the water directly recharged into the bore. So this is the direct technique by which you can recharge the groundwater directly. So we have seen the first method of recharging, that is rooftop rainwater harvesting into existing actual bore. The most suitable recharge structures for rooftop rainwater harvesting: recharge pits and recharge trench. Recharge pits suitable for alluvial areas where permeable rocks are exposed to very shallow depth and for rooftop areas of around 100 square meter. While recharge trenches are suitable for building having rooftop area of around 200 to 300 square meter. Suitable for alluvial areas where permeable rocks are exposed to very shallow depth and for rooftop areas of 100 square meter. Recharge pits. Recharge pits may be of any shape and size and are generally constructed 1 to 2 meter wide and 2 to 3 meter deep. The recharge pits are backfilled with boulders, gravels, and coarse sand in graded form: boulders at the bottom, gravels in between, and coarser sand at the top, so that the silt content that will come with runoff will be deposited on the top of the coarse sand layer and can easily be removed. For smaller roof area, pit may be filled with broken bricks or cobbles. Periodic cleaning of topsoil layer is must for recharge pits. This is again a system which shows the recharge pits, and the water from the roof that can be taken into the recharge pit, and through recharge pit, if there is a bore recharge well, that will take the water underground. So this is the recharge pit which is constructed in SVNIT, and you will get opportunity to see this personally when you will be here in the campus. This is the one of the hostel. You can see here in this picture, this is the rooftop. Yeah, this is the rooftop, and these pipes comes out from the top of the building, which goes like this. It comes like this, and then afterwards it comes into the recharge pit, and the water, see the quality of water also, which is pure quality water, which is drained into the recharge pit. Here is the recharge well, which is having slits, openings on the sides, and water which is collected in this pit through these slits enter into this pipe, which will recharge the ground. I'll show you the video of this also, wherein we can have the water which you can use for the purpose of recharging. A small video is here. Is it possible to see this video?
Yes, sir.
Yes, sir.
Yes, sir.
So this is captured in the last rain. You can see the pipe which I have shown. This is the outlet pipe which I have shown you in the picture from SVNIT hostel top. So this is the actual rain condition, and during rain, the water, just see here, this is the water which is collected from the top of the roof of the hostel building, which infiltrates into the pit, and from pit it will be recharged into the ground through the pipe which is placed in the center of it. So this is the second method of harvesting rooftop water through recharge pits. While the recharge trenches suitable for building having rooftop area of 200 to 300 square meters, trench may be 0.5 to 1 meter wide, 1 to 1.5 meter deep, and 10 to 20 meter long, depending upon availability of water to be recharged. The backfilling materials are same as recharge pits. Sometimes when you see these slides, you feel that, sir, who may be using such type of recharge trenches for recharging of a groundwater. Let me tell you, in Madhya Pradesh, specifically the Mandsaur district, there the farmers built a farm pond in their farm, in a corner of a farm, and they store the monsoon water, rainfall, into it, and then they use it for watering their crop for 2 seasons. And you will not ready to believe that the entire societal status, economic status of the people of that region has been changed. This particular experiment has been carried out first by one farmer, and then afterwards the government, the local authorities, they also help them, and even the banks have provided loan for constructing such a farm pond in their farm, which collects the rainwater which they uses for the monsoon period, as well as the one season for taking crop after one season, that is after the monsoon season. The recharge structure, recharge through dry or operational dug wells. The recharge through dry or operational dug wells, if exist in the area, may be utilized as recharge structures after cleaning and desilting the same. If there is a dug well wherein you can take the water and after what you can say providing in the filter medium, properly cleaning it, it can be discharged into the dug well. So this is the again a schematic diagram where his roof is kept. This is the filter media through which the water will pass, and then afterwards it will be discharged into the dug well. I have one video of this dug well. I am not showing you over here, but you can, I'll share my YouTube channel link, and on that YouTube channel link, I have placed this video, uploaded this video, wherein the water from the roof, surface water, that is discharged or used for recharging of the dug well. Recharge structures, recharge through abandoned tube well. So abandoned or existing tube wells. So I have already shown you the video where the rooftop water is recharged into existing tube well. In the same way, if there is an abandoned tube well, after cleaning it, after properly cleaning it, you can able to put the rooftop water into it. This is the sketch which shows how the recharge valve can be constructed into it, and where the water, if there are impervious layers in between, the water may be taken, or the recharge well may be taken, abandoned well may be taken up to the porous formation, and the water may be diverted, the recharge water may be diverted into this recharge well. So abandoned well, it may be in your campus, it may be in your society, it may be in your area where you find such type of abandoned well. After putting small efforts, you can use it for the purpose of recharging. The recharge structures, recharge valves, already I have discussed about this. The recharge structures, recharge shafts. Recharge shafts or choke away or recharge shafts are provided where the upper layer of soil is alluvial or less porous. There are the bored hole of 30 centimeter diameter up to 10 to 15 meter deep, depending upon the depth of the previous layer. Bore should be lined with slotted perforated PVC MS pipe to prevent the collapse of the vertical sides. If we'll get opportunity, when we'll be visiting the Sumulderi campus, basically Sumulderi campus, we are going to visit on Monday, that is 12/12/2022. On that day, we'll be visiting the Sumulderi campus and actually going to observe the recharge wells constructed there. And if possible, I'll show you the slotted or perforated PVC and MS pipes, how they are used for the construction of the recharge shafts or recharge valves. At the top of the soakaway, the required size sump is constructed to retain runoff before the filters through the soakaway. Some should be filled with filter materials. So this is the recharge shaft. You can see here, this is the lead. Then the closed slotted PVC pipes, clogged layer, imperious cement layers, and through this the water is injected into the ground. Specifically, this particular figure, recharge shaft, the agency which will be visiting on 15/12/2022, they have developed this particular recharge shafts in a very big way, and that has been used for industrial purpose. When there is a if there is an industry and that have a large area, and there they wanted to do recharge in terms of large quantities, they have derived the techniques which are used for diverting the water into the ground. Probably they will show you the video of this recharge shafts, how they can be used to divert large quantity of water into the ground, which cost in terms of lakhs of rupees. Simple recharge well may cost in terms of 1 lakh rupees, around 1 lakh rupees or so, but if the large quantity of water is required to be diverted, it costs in terms of lakhs of rupees. So this recharge stops, and using the mechanical actuator, because the pipe size is larger, the size of the storage tanks are larger, and they are diverting the water into the ground, there they have used the mechanical devices for operating of this recharge well. Probably you will be able to see it on 15/12/2022. The maintenance of this system, the catchment should be neat and clean. The very first thing for rooftop water harvesting is that you should not allow the first rainwater to drain into the recharge well. Why? Because the roof may not be clean. You have to allow the first rainwater to flush out. Flush out means not allowing it to go into the recharge well. The washing machine, water having heavy dose of detergent, should not be allowed to enter into the water drains which are connected with the recharge structures. Protect the drainage system from tree, leaves, polythene bags, plastic bottles, and purchase of and pouches of eatables that should not go into the recharge well. Precaution should be taken to avoid domestic wastewater not entering into the recharge structures. Before the arrival of monsoon, the rooftop as well as drain should be properly cleaned. A wire mesh should be placed at the entrance of recharge structures. To take care of this, that after the first monsoon, the water is flushed out and it should not enter into the recharge valve or recharge bore. There are filters, ready-made filters available in the market. I'll show you these ready-made filters physically during our offline classes. At the same time, I will show you the working of these filters during the offline classes, as well as the videos of it, that how the design filters work even after the first rainfall. Means after first rainfall also that water is flushed out, but after first rainfall the water is drained into the recharge well. But if it carries any impurities like leaves, leaves, etc., then these filters automatically take care of it and it throws it out. It will not allow it to go into the, what you can say, recharge valve. The another form of rainwater storage tank under traffic area, you can see here that this concept is also used, wherein you can see rainwater harvesting system, which is heavy duty geocellular modular rainwater storage tank, bearing capacity is more than 600 kilonewton per meter square, excellent for rainwater storage tank built under the traffic conditions. So these are also used for the purpose of, what you can say, conservation of water. The rainwater harvesting system in case of open area, you can see here, these are all the rainwater harvesting valves. These are wherein small openings you can see over here. So whenever there is a rainfall on this area, this surface water get diverted through these walls into the recharge well or recharging system, ultimately infiltrates into the ground. This is again a rainwater collection system which is shown over here for harvesting of the rain. This is another rooftop rainwater harvesting system in which a pipe is outlet pipe from the roof that has been, the water has been diverted into the drum, which is same as that which has been used in case of the video which I have shown, having the filter media and the water. And you can see the outlet pipe is not at the bottom, it is at the top. So the clean water which will be collected in this, that will get finally diverted into underground tank or the groundwater. This is again a rainwater storage for gardening purpose, where the roof water can be stored and later on can be utilized for the purpose of the gardening. In case of SVNIT, we have number of recharging structures and all use rooftop rainwater, which is used through the recharge pits and this recharge valve, bore valve, which diverts the water into the ground. Here in this picture, third picture, you can see that the outlet is here and there is approximately 6-inch depth of water in this valve, and through this filter medium it get percolated into this particular pipe. This pipe we have a slotted openings, and this clean water slowly get recharged into the ground. This is another system, rooftop rainwater harvesting system. This is also an educational building. You can see that this is the outlet pipe. Here is also an outlet pipe. Both the outlet pipes are connected with the downtake pipe, which carries water finally. Yeah, here you can see this pipe wherein there is a valve, and here also this is a valve. So during first rain, this valve is kept closed and this valve is kept open. So first rainwater is not allowed to go into the underground storage tank, but this valve is open, so it will flush out. And after the first rain, this valve is closed, this valve is open, and the clean water will allowed to go into the underground tank. So maintenance, already I have talked about that you have to clean at the end of the dry season and just before the first hour of rain is anticipated. The storage tank should be scrubbed and flushed of all sediment and debris. Ensure timely service of all tank fixtures, including replacement of all worn screens and servicing the outlet tap or hand pump. Nowadays, like we have storage tanks in ancient time, we can construct a underground storage tank. And as you know that sunlight, if the sunlight enters into the underground storage tank, that will develop the microorganism or what you can say biological activities, and therefore the tank is required to be closed tightly. But when you want to take out water from this underground tank, we may need to open it. So there are chances that during that time the sunlight may enter or debris may fall into the water, and which may become a source of pollution or source of polluting the water. And therefore now a small pumps are installed on underground tank, so that you are not required to open the tank. With the hand you can pump water out of the tank without opening it. So such tanks are also available in the market. When it comes to the cost, the video which I have shown you, in which we are diverting the rooftop rainwater into the existing bore well, the total cost of the system is less than 1,000 rupees. When I'm talking of the pump which is installed, which can be installed on the top of the tank, which can be used to pump out the water from the underground storage tank, hardly cost 1,000 rupees. So it is not that the recharging of ground or storing of water is always a costly affair. It is as simple as less than 1,000 rupees. And as I have explained you, when there is a large shaft, recharge shaft, it may cost in terms of lakhs of rupees. So design planning in Surat, the Surat Municipal Corporation has taken initiative, and they have already completed 90 rainwater harvesting system, and 500 more rainwater harvesting structures they will be installed in next 3 years. The Surat Municipal Corporation has come out with the subsidy. If you have a house and if you want to construct a recharge well, they give the subsidy up to 80%, depending upon that which area you are staying, which type of recharge well you want to construct. For that, you have to apply to hydraulic department, and once it is approved, they give you subsidy to construct recharge well in case of city of Surat. This is a video of working of filter that I will show you later on. This is the picture of filter. This is the pipe which comes from the rooftop. When this is open, the water will not go into this pipe. It will come into it and it will flush out. While when it is closed, it will go into this pipe, and this is the filter medium through which the water will be filtered out. And here you can see that the platform is there. So outlet pipe is below this filter, where the clean water will be stored into the storage tanks. So this is all about methods of rooftop rainwater harvesting. If you have any questions, or any questions are there in the chat box, I have not seen it, you can ask me.
Participants can unmute and ask the questions.
Any one of you have such type of a recharge system in their house or in their society? Participants in their institute? If not, then you can plan this, right? This is very cost effective, and you can construct this recharge system, specifically rooftop rainwater harvesting, either in your house or in your society or in your educational institute, right? So one of the aim of organizing this STTP is that the participants who are attending this STTP carry the message of water conservation and start implementing it from their own house or own society or own institution. I do not know, some time back I asked Darshan to take up this activity in their campus, GEC Surat. Darshan, are you there? Darshan?
Hi, yes, sir.
Yeah, and what is the status now in your campus?
Sir, we have identified the point and planning to install it in one particular department. So right now it is in planning stage, sir.
And this Urvis is saying that they have designed the rainwater harvesting system in Faculty of Technology and Engineering, MSU Baroda, and constructed a MSU Baroda Pavilion campus. Urvish, let me inform you that Dr. Surya Narayan is one of the faculty, and he is the person who has constructed number of rainwater harvesting systems in MSU campus. And he will be sharing his experiences, I think second last day, right? Where he will be showing you that how he has done. Because in Baroda, most of the hostels, most of the university buildings, right, they are designed for rainwater harvesting system, and they are capturing water. Anybody else?
Sir.
Yes. Pradeep?
Sir, in our campus, they are using the percolation tank technique for the rainwater harvesting at Sasid, Surat.
That's great. That's great. But only they have made a percolation pond, Pradeep, or they have made the recharge shaft or recharge valve into it?
In that percolation tank, they are providing the recharge
well as well. Yeah, that recharge well as well. Right. So this design, Pradeep, this design of percolation tank and the recharge well, that will be one session in offline SCTP. So you can design it, participants, you can design it, the percolation tank as well as the recharge well system. You will learn it in our offline session, and that also you can design after attending this particular SCTP. Any question?
Thank you.
So Shalin is also writing rainwater harvesting is available in our KGISL college, Coimbatore. So those who are having this rainwater harvesting system in their campus, and if they are visiting their campus, they can post the pictures of it in our FDP group. Yes, Nabrata ma'am.
Sir, Dharmendra here.
Yeah, please, sir.
Sir, actually, I am in GP Navsari, and it is at the coastal, near the coastal
areas. Yeah.
And the water table at the particular college is from the 10 feet below the ground level.
Yes,
so,
it is.
So which technique is right now? It is give the benefits to the rainwater harvesting. We are planning with the R&B department, but actually we are failed for the recharging.
True. As therefore I have pointed out participants that the recharge well is suitable when the water table, recharging technique is suitable when water table is 8 meters below the ground level. If it is above 8 meters, means when the water table is close to the ground, in that case, only the recharge well when I'm saying that means the bore well, right, which is of considerable depth, that will only help for the recharging purpose. But that too, again, you have to see what is the condition of the ground, right? If you have the underground reservoir, aquifer, and that too fully saturated, if that too is fully saturated, then the only option is you can go for spreading method, that is construction of tank,
pond like,
not percolation tank, right, with lining which can store the water for considerable time period. But again, if you are doing for that, then the utilization of water is a question. For example, if I take up Hazira region, in Hazira region, lot of industries are there, and they are not getting the fresh water, and therefore they have constructed such type of a pond wherein they laid the PVC sheet so that the percolation of water become minimum. They can store both rainwater as well as the water which they pump from Singapore weir, which they use for the industrial purpose, and they store into it. So such a type of a technique can be used when the water table is very close to the ground.
Thank you, sir.
So if there is no any other question, then we will end our today's session over here. And there is an announcement that tomorrow, instead of 7 o'clock, we have to join at 5 o'clock. As Dr. Dhalla, he is director at NTU, Nanyang Technological University, Singapore. And he will be joining for delivering a lecture at 5 p.m. Our India time is 5 p.m. For them, it is, I think, 8:30 p.m. So if we arrange at 7 p.m., it becomes midnight for them, and therefore he will be delivering the lecture at 5 p.m. So all are requested to join at 5 p.m. Rashmi, I think the same link is useful for joining at 5 p.m.
Yes, sir.
Yes.
No need of another link. The same link they can use.
Yes, sir.
Okay. So I thank you all for your patience listening and joining the session. So we'll meet again tomorrow evening 5 p.m. Thank you very much.
Sir,
Yeah,
I would like to request all the participants to switch on their camera.
Yeah. One peek is required. Please turn on your cameras so that we can take one peek. All are requested to turn on their cameras so that we can take a pic. Ayushi, are you taking the picture?
Yes, sir. All the participants are requested to switch on their camera. Okay, sir, it's done. Okay, sir. Thank you.
Are you done?
Yes,
Okay,
sir.
okay. Thank you everyone, and we'll meet again tomorrow at 5 p.m. Thank you.